Hi, my name is Leslie, and I'm here with my coworker, Derek Stoley, on behalf of the Git Fundamentals team to talk about the future of Git at scale. Before we dive in, though, Stoley, how about you tell us a little bit about yourself?
Thanks, Leslie. As a software engineer at GitHub, I've been contributing to the core Git project for 4 years now, with a focus on performance. Some of my greatest hits include the commit graph file, the multi-pack index file, as well as making Git log graph work really quickly.
Great, thanks for the background. While I'm new to GitHub, I've spent the past few years of my career working on Microsoft Office. Specifically, I focused on moving the Office codebase out of its over 20-year-old homegrown version control system onto Git. So, although I've only been a hubber for a couple months now, I feel like you and I have been partners in crime forever, Stoley. So, are you ready to do this thing?
Absolutely. I can't wait to share all the new ideas that are brewing in the Git community. We have ordered these ideas so that the first ones apply to every repository, no matter how small, but we will extend to the cutting edge features that are enabling developers in our largest Git monorepos.
Okay, first things first. We're going to be chatting about a lot of new Git features today. And the best way to make sure you are able to enjoy this goodness is by upgrading frequently. A new Git release drops every 12-ish weeks, so make sure to keep an eye on the applicable code base, either Git or Git for Windows, so you can access the latest and greatest features as soon as possible. All right, now that we've covered that, let's move on to some features. I remember when I was working in the Office Git monorepo that there was some special maintenance happening behind the scenes to keep things like fetch fast. I'd like to pass it to Stoley to talk more about how that works.
In the Office world, they're using a tool called Scalar that has a lot of helpful features, including running Git maintenance in the background. This keeps users' data well organized without blocking foreground Git commands. I'm happy to say that now we have contributed that background maintenance as a core Git feature. The Git maintenance command integrates with your platform's scheduler to run certain maintenance tasks on hourly, daily, or weekly cadences. To try this out, just run git maintenance start in your favorite repositories. Then forget about it. One helpful feature is that Git will start fetching data from your remotes every hour. This means that your Git fetch and Git pull times will improve as you're mostly updating your remote references and getting the small amount of data that was pushed in the last hour. You no longer need to dread that first long fetch on a Monday morning. Other benefits include keeping your repository data well organized without needing to run garbage collection at the end of a Git command. The initial maintenance schedule is one that we've been using for a while on our largest monorepos, and it's proven effective at keeping users happy. If you want to dig into the nitty-gritty details, then you can customize this schedule using Git config settings. So we've talked about keeping your Git versions up to date and keeping your repositories in good shape. Let's talk about keeping your Git data safe.
Sure, let's talk auth. Historically, the Git auth experience across platforms has been somewhat fragmented. However, when Office began its transition to Git, it became clear that an improved cross-platform tool would be required to make the transition successful. Thus, Git Credential Manager Core, better known as GCM Core, was born. This is a cross-platform, multi-factor credential manager for Git that provides a universal authentication experience. Because of GCM Core, as an Office engineer working in Git, I rarely ever thought about auth. Here's how it works. GCM Core occasionally prompts you to click a button to sign in with your browser. You complete MFA, then get a notification that authentication succeeded and return to your work. Meanwhile, GCM Core persistently stores a special token in your platform's credential manager so that you don't have to worry about auth until it expires, at which point the cycle begins again.
Why do I need a helper like this? Isn't a username and password sufficient?
Well, we know at this point that username and password auth is just not very secure. In fact, GitHub has disabled it entirely in the name of safety. Basically, when your password is compromised, your account and all the information within is also compromised. Just think how easy it would be for a bad actor with your password to start doing fishy things to your repos. It's much, much better to use a solution that supports MFA, which, as shown on this slide, GCM Core does.
Is this just a GitHub feature? Do I need something else to authenticate with other services?
GCM Core is already available for GitHub, Azure DevOps, and Bitbucket. It also has a great plugin architecture for other providers to contribute their own authentication mechanisms in the future.
How can our audience get started with GCM Core?
On Windows, GCM Core is installed and on by default. On Mac OS, you can use Homebrew to access the Microsoft Git tab and install as shown on the slide. Finally, for Linux, you can download and install the Debian package from the repository's releases page or install from source, then run Git Credential Manager Core configure.
These features we've talked about so far are things we couldn't wait to share because they are so critical to working painlessly with Git. They apply to all users, but let's shift gears to my favorite area, performance. Leslie, you've got a feature for us that users can enable in their repositories for immediate impact.
That I do. But first, let me give a little context. We're going to be using 3 basic shapes to illustrate concepts throughout the rest of the presentation. Circles represent commits or points in time. Triangles represent trees or directories. And boxes represent blobs or file contents. So we've used some alliteration with C, T, and B. Hopefully that helps make things easy to remember. Okay, now that everyone's familiar with our shapes, let's zoom in on a hypothetical head commit. This commit has a root tree, which contains blobs, and other trees, which in turn contain more blobs and trees. Now, when a user runs a command like git status, Git has to start walking directories to see what, if anything, has changed. Now, clearly, this quickly results in a lot of work. And as you might guess, as repo size increases, this querying of the file system gets slower and slower, and users get more and more frustrated. This is where FS Monitor comes in. It alleviates this pain by helping Git avoid unnecessary disk reads. FS Monitor works with tools that constantly watch the file system for changes so that it's readily able to provide a list of quote unquote dirty files when Git requests it. To put this concretely, on the Windows platform with a repo containing over 2 million files, enabling FS Monitor helped reduce status times from about 23 seconds to about 6 seconds, and diff times from 13 seconds to closer to 1 second. Although these times are great improvements, we realize they still aren't ideal for Monorepo engineers. Don't worry though, the rest of our topics today will address that. The commands on this slide show the 2 different ways to enable FS Monitor in your repo. The first uses a special hook that works with Watchman, an open source file system watcher that you'll need to install separately. Note that while Git does provide a template for this hook, some customization is required. We're also rolling out a new daemon that's built into Git itself and removes the overhead associated with the hook as well as the Watchman dependency. Not to mention, it's a lot easier to configure. This daemon is already available in Git for Windows, with a macOS version currently being contributed to core Git. Finally, when using FS Monitor in your monorepo, you'll want to make sure you also enable the untracked cache to ensure you maximize performance benefits for your repository.
FS Monitor is great at improving performance in repositories you are already using. You don't need to interrupt your workflow by starting from scratch. I want to talk about another way to improve performance through Git's partial clone feature, but it does require recloning your repository. Before I can talk about partial clone, I first need to talk about what it means to be a normal full clone. When you run git clone, the Git server needs to send a certain amount of data to you. We start with the full commit history from the cloned branches. Each commit has a root tree, and then we drill down into each tree to discover more and more of the Git objects until every possible link has terminated in a blob. When we're thinking about clones, Git downloads every reachable object. This is due to its distributed design. You have absolutely everything you need to be able to do your work, including the full history of every file. These copies of old versions of files can be a significant portion of the repository data, and you as a user are less likely to need that data except for a few paths where you specifically request the history. This is where partial clone comes in. It relaxes that distributed model by allowing you to ask for data from the remote on an as-needed basis. You can create a new repository using partial clone by running git clone --filter equals blob:_none. This creates a blobless partial clone, which is our recommended filter type. A blobless partial clone is exactly what it sounds like. You get all reachable commits and trees, but no blobs. The blobs are filled in when you need them, such as when you check out the tip commit and need the blobs reachable from the root tree. The trade-off here is you need a network connection to do certain operations, such as checking out a commit for the first time or running git blame. Once you've downloaded the blobs you need, you're free to disconnect and work on a bus or a plane. Using partial clone can greatly reduce the time it takes to get started working in your repository, but also your git fetch and git pull times will speed up too. Leslie, you have yet another way you can reduce the size of your repository, right?
Sure do. Let's take one last look at how much data was downloaded with partial clone. We've got all the blobs and all the trees ahead, but what if there were a way to reduce this data even more? Well, we have great news. There is. As you can see, adding a special feature called Sparse Checkout restricts the working directory to only the files you care about. Along with FS Monitor and partial clone, Sparse Checkout pretty much enabled Office to make the transition to Git. In a repository of over 2 million files, developers were able to limit the scope of their files on disk to only the components they really needed for their day-to-day work. So how do you get going with Sparse Checkout? Just run the commands shown on this slide in your Monorepo. I do want to briefly touch on the cone flag in the first command, though. This initiates your Sparse Checkout in what we call cone mode, which is highly recommended as it enables pattern matching on directories rather than files, which gives you yet another performance boost and unlocks the next feature we're going to talk about today. Another important note about Sparse Checkout is that it's designed to work best in componentized repositories. We were lucky in Office that we'd already set up our code base and build systems to work without the entirety of the code base on disk. Engineering teams managing large monorepos that aren't clearly componentized should take this into account when deciding whether Sparse Checkout is the right tool for their repository. Wow, we have made it through a lot of features, but we're not done yet, are we, Stoli?
We sure aren't. However, in order to talk about a really new feature in Git that improves how Git works at the extremes of repository size, we first need to step back and think about the user experience. Leslie, since you're in the unique position of being a customer turned contributor, want to provide some background here?
As I mentioned previously, Sparse Checkout, Partial Clone, and FS Monitor proved to be more than good enough to satisfy the needs of many Office product engineers migrating from the old version control system. In fact, we were so impressed that we wanted to merge other Git repositories into the Office monorepo. These repos were a list of much smaller repositories that contained JavaScript code in support of O365 and other web UI projects. However, engineers coming from these small repositories saw some unexpected performance differences. The team set out to determine the root cause of these issues, and the culprit was soon revealed: the index. Stoli, can you share more about the team's process here and how the fix is progressing?
The Git index is a critical data structure. When you use git add to stage a change, that is stored in the index. When you run git commit, the data in the index is used to generate a commit. The index contains a list of every file it had, along with some information about the file system state the last time Git looked at these files. In this figure, I've highlighted a small sparse checkout cone within the larger monorepo. While the number of populated files in the sparse checkout cone is small, we still list every file it had, even though they are marked as not being written to the working directory. For users in the Office monorepo, the index file is about 180 megabytes. This data is parsed into a flat array, operated on, and then rewritten entirely in commands like git status, git add, and git commit. These commands are expected to be fast, but they are doing a lot of work at this scale. Remember when we talked about cone mode sparse checkout? That allowed us to match paths based on directories, which is critical. If we know that an entire directory is outside of the sparse checkout cone, we can do something radical. We modified the index format to allow adding sparse directory entries. These rows of the table store directory paths with the ID for a tree object. This means that as soon as we leave the sparse checkout cone, we can store a single entry to represent all paths within that directory. This results in a sparse index. This greatly reduces the size of the index. Instead of 180 megabytes, most Office monorepo users will have an index size of less than 10 megabytes, removing that bottleneck.
Now, this seems like a relatively simple idea to explain. Why wasn't this done already?
Well, there are two aspects. First is that we really need cone mode sparse checkout patterns to provide directory-based path matching. Without that, we cannot determine the entire directory is outside of the sparse checkout cone. Cone mode sparse checkouts were only introduced 2 years ago. The second issue is that there are a lot of places in the Git codebase that interact with the index, and all of them are expecting a flat list of file names. We have been working to incrementally update Git commands one by one to understand a sparse index and do the correct thing when encountering these sparse directory entries. That work is paying off, and I want to share some performance results. Again, in the Office monorepo, I have the wrong picture here, unfortunately. Sorry about that. In the Office monorepo, we have things like git commit, git status, and git add are dropping from about 1.5 seconds to less than half a second. Even commands like git checkout are getting benefits, such as one example going from over 4 seconds to under a second. These numbers are on top of the existing benefits from sparse checkout and the built-in FS monitor.
It seems like these improvements are crossing a threshold where Git starts to feel really responsive instead of users needing to sit and wait for each command to finish.
Exactly. Here we have a visual of how users perceive interactions with a tool like Git, ranging from immediate to unusable. These features we've talked about have improved working in a monorepo like Office to be well within the responsive category. We are intent on discovering the next generation of Git features that will push the boundaries of Git at scale even further.
Absolutely. All of these features are really taking Git's performance in monorepos to the next level. I can't wait to continue to see results as they roll out more widely to our user base. And that brings us to the end of our list of features for today. And holy moly, what a whirlwind tour of things happening in the Git space. It's been a lot of fun. Before we leave, though, we have to give credit where it's due. I'm so proud of all the work the Git Fundamentals team is doing, which goes way above and beyond what we were able to talk about today.
Absolutely. I can't imagine a better group of people to build cool stuff with, some of which I'm so glad we got to share today. Finally, none of this would be possible without the contributions and review by the entire open source community that keeps Git thriving. Thanks for tuning in.
Awesome. Thanks, folks. And I'm glad Derek threw that classic lecturer's trick in of putting the wrong slide in just to wake everybody up. It wasn't your holiday photos, at least. So it's good. Right, I've got a couple of questions from the audience. Remember, if you've got questions, stick them in the Slack channel and we'll bring them up here. The first one is from Alex Ellis. Frankly, you blew people's minds away with Git maintenance. This was like the command that nobody knew known about before. So Alex was asking, is there any benefit running it Is there any benefit running it interactively ad hoc, or is it just to run things that happen usually upon a push-pull? So should I run it interactively?
So the git maintenance command has a lot of flexibility. For instance, you could do git maintenance run and then specify which tasks you want to run. So you can do that at an ad hoc basis if that's what you prefer. I'm of the opinion that I want to set it and forget it. And so having it run in the background and do all that things like fetching in the background, doing repacks every night, packing my refs every week, that schedule is well hardened and is going to probably get you what you need. But if you feel like, hey, I just did a bunch of things, I have all these pack files, I want to clean them up right now, you can do it that way. If you prefer to do something like a GC every week, currently garbage collection is not in the list of things because it's not necessarily super safe to do while you're also running git foreground commands. So these sorts of things are the things to keep in mind. But go take a look at the docs. Hopefully they are sufficiently detailed, and give it a shot.
Awesome. Thanks. Ashley, one for you. Why did the Office team decide to move more projects into the monorepo rather than splitting them out into multiple monorepos? What are basically, I guess, what are the benefits that they found in terms of productivity of working in a monorepo, I guess? Because that seems like the only reason you might do it. Otherwise, it's crazy talk.
It does seem like crazy talk. And I will be honest, I was not actually the most privy to those discussions. I focused more on the Office product engineers. So Stoli might actually be in a better situation to answer this question.
Essentially, that these repos that live outside of the monorepo, they do contribute to the Office product as a whole. And so when you're saying, I want to say, what version is the Office website in right now, like the O365, it includes these packages from JavaScript. And has this complicated way of knowing which version of those Git repos are actually getting deployed at a certain time. And also that they have dependencies within each other. And so all of that dependency management, they're finding that it's so much easier to deal with as a Git monorepo as opposed to the multi-repo scenario and dealing with package managers, especially because they want to do things like code sharing, and having all these different components are solving similar problems. So why not have that be solved in one way? And then they can all depend on it. And in the monorepo environment, they can do that.
Got it. And then probably, one question from me, actually. Office is currently on Azure repos as the backend for the Git server. What do we think it's going to take to get them over to GitHub, or is that never going to happen?
I will definitely take this one. So Office is extremely focused right now on getting all of their product engineers into the monorepo. They decided, instead of doing kind of a big bang transition of getting everyone over, to incrementally move over different teams. And while that was definitely a safer way and a way that made more sense based on the way the Office code base is structured, it has taken a lot of time. So right now, from the Office end, the focus is just getting everyone into the monorepo, onto Azure DevOps. And then, okay, once that's done, we'll maybe try to transition to GitHub. Now, on the GitHub side, it's my understanding, and you can correct me if I'm wrong, Stoli, but it's my understanding that the scale isn't quite at the same level as the Azure DevOps backend, which was built out to support repos like the OS repo. So we have some work to do on our side of things as well in order to support a repository of that size.
You're absolutely right, Leslie. GitHub does have fantastic scaling, more than anybody else, but it's really wide scaling, right? Millions and millions of repos are on GitHub, and millions of users. And so scaling to that amount, and also to like the idea of the public interface, GitHub is absolutely an expert at that. And what we're going to do over the next few years or months is try to figure out exactly where are the pain points for GitHub to scale at that size, and with the goal of having Office move over. One nice thing about Office using the features we've been talking about today, partial clone, sparse checkout, they are well suited to be able to transition to GitHub. And the only difference the users will experience is where do they go to complete pull requests. Things like the Windows OS repo, they are using a tool called VFS for Git, which does some file system virtualization things, and that is really tied to Azure DevOps. They would need to transition to Sparse Checkout first, and then be able to transition to GitHub. And so that's another direction we are pursuing. But at least we're on the right track with Office, that by depending more on native Git tools, they're ready to make that transition.
Makes sense. And then the last one, which I'm going to use to kind of summarize a lot of the meta questions and things. Where's the best place to like hang out to keep up to date with the new Git features, like Git maintenance, and like some of this stuff arrives all the time that I didn't know existed. So where should we be hanging out to like learn about this sort of stuff, just in core Git?
The super light version is watch the GitHub blog. At least every other version, we post something that's a brief version of the release notes with some focus on some of the more important things. Like background maintenance was announced that way, for instance. The next round to go is to watch the git/git repo on GitHub, and you'll see when they push a tag, and it includes the release notes, which are very detailed, and it includes anything like every single topic branch that got merged in that window. And then if you're really hardcore, you can go and watch the Git mailing list and see everyone, communicating and developing this in real time. But that is a huge amount of information. It's really hard to distill the critical things from there. So I recommend at least getting to that release notes level of detail.
Awesome. Any tips from you, Leslie, or is that good?
I think he about covered it. If you're feeling really brave of heart, join the mailing list. That would be
If
my.
you want to learn new swear words from Linus, join the mailing list.
Yeah.
Awesome.
Yeah.
Fantastic. Well, thank you very much, both of you. That was we should have dusted our propeller hats off early. That was superb. So I appreciate you going in depth there into Git in our first session, showing us what to do. So yeah, thank you very much, and thanks everybody to Stoley and Leslie.